What did we discuss? Yes. Mridula, Hamna, am I clearly audible to you guys?
Ma'am, we were studying the polynomials.
Yeah. So we're talking about polynomials, but what were we talking about polynomials? So we talked about the different types of polynomials, right? The different types of polynomials. Would anyone like to recall what were the
Ma'am,
different
the
types?
types of polynomials are monomials,
Yeah. So
monomial,
there are different types
binomial,
of polynomials.
trinomial.
Yeah. So monomials, binomials, and trinomials are special types of polynomials. And then we talked about the power of power of a term, right? We talked about terms. We talked about coefficients. We talked about power and the degree. So we said that the degree of a polynomial means the degree of the basically the highest degree in that polynomial. So let's just do some questions to revise what we studied in the previous lesson, and then we'll move forward. Okay. So yeah. All right. So we did the first one. You guys remember, right? We did the first one. No doubts about
Ma'am,
this.
yes, ma'am.
Yeah. Then the second one. Okay. Who's gonna give the answer first?
Ma'am, D.
Sorry, who was that?
Ma'am, D.
D. Okay. Root 2 is a polynomial of degree, and Mridula says it's half. Okay, Hamna, what do you think?
Ma'am,
Yes?
B.
B. Degree 0. Okay. See, Mridula, is it possible to have a polynomial of degree half? Is it possible?
Yes, ma'am.
Can you give an example?
Ma'am, 2 raised to the power half.
2 raised to the power half. So is this a polynomial? Like, okay, what do you mean by degree of a polynomial? Does degree mean, just recall what we studied in the previous class, does degree mean when you have an exponent on the coefficient, or does degree mean when you have an exponent on the variable? Which of these is degree?
Ma'am, first one.
Achha, so this, you're saying this one is a degree. No, Madhula, this is not exactly the degree that we're talking about when it comes to polynomials. See, let's just revise what a degree is. Okay, so we took an example. We said that polynomials are basically, you have a polynomial is a polynomial is a sum of a finite number of terms. That means there can be any number of terms. There can be 10 terms, 20 terms, 1000 terms, any number of terms, but it has to be finite, right? You can't just go on till infinity. So it is a sum of a finite number of terms. And what are those terms like? What do they look like? They have a special feature. And that special feature of these terms, when we're talking about polynomials, because we have to be very careful about it, the terms are of the form, you have a coefficient. Okay, this is what a term looks like. There's a coefficient, then there's a variable, and the variable has to it an exponent, and this exponent is called the power of this term, or I'm sorry, or the degree of this term, right? So Mridula, according to you, what should be, what do you think the coefficient can be? So this is the coefficient. What do you think the coefficient can be?
Ma'am, a real number.
A real number. So if I have, sorry, if I have a polynomial, which is like, let's say it is root 2, okay, and root 2 is nothing but 2 to the power half, right? So if it is 2 to the power half, x to the power, let's say 3 plus, or well, let's make it minus, minus pi x to the power 2. Okay. So Mridula, is this a polynomial? Mridula, can you hear me? Yes.
Ma'am, I'm not sure about it.
You're not sure. Okay, Mridula, so do you guys want to revise what we did in the previous class again? Do
Yes,
you want to
ma'am.
go through the basics? Okay. So we saw that, again. I'm gonna write it down again, and please pay attention. Okay. So a polynomial. Just a sec. A polynomial is, and we saw a lot of examples of polynomials. Okay. So we had 10x to the power 4 plus 3x square minus 7x cube, for example. Okay, this is one example. Another example is 5y square plus 7.5 y. Another example is, let's say, 1 by 4 t cube minus 3 by 4. Yeah, that's it. So these are all examples of polynomials. And then we said, what is not an example of a polynomial? What is not an example of a polynomial? We said, well, if we have something in any of these powers, any of the powers of x, okay, the powers of the variables, the powers of the variables should not be in negative, and it should not be in fraction. Basically, it should be, what should it be, Hamna? Do you remember?
Should be a whole number.
Yes. So the power of this variable should be a whole number. So if we have something like, Hamna, do you want to give me examples of algebraic expressions which are not polynomials? Yes. Come on, come on. Hamna, am I audible?
Yes, ma'am.
Yeah.
9y raised to the power 1 by 2.
Okay. So this is not a polynomial. Mridula, would you like to give another example of something that is not a polynomial?
Ma'am, 10t raised to the power 4 by minus 4 by 3.
Very good, right? So again, this is not a polynomial. So then we ask, okay, how do we define, how do we know what is and what isn't a polynomial? So for that, the definition that I just, it's an informal definition. So the one that we just saw in the previous slide, a polynomial is a sum of finite number of terms. Okay, sum of terms. So basically, you will have a lot of terms of this form. A, where a is a coefficient, and then you have any variable. It could be x, y, z, t, right? And then that variable has a power to it, and this power could be any whole number. It can be any whole number. And I'm sorry, this coefficient can be any real number, as you guys recalled. So this is one term. When we are saying that it is a sum of terms, that means there are going to be many terms like this. So there's going to be another term, which is like something else. Let's say it is b. It's not going to be the same coefficient, right? It will be, could be something else. So that's why I'm using b. You'll have the same variable over here, and you'll have another integer, right? So you can have many terms like this. Okay. Now, back to our question. What is degree? We said degree. So let's take a look at this, the first one, the first example over here. In each of, just a sec, in each of these terms, can you, Mridula, can you tell me the power of each of, okay, first of all, Mridula, can you tell me the, what are the terms in the first one over here? What are the terms?
Ma'am, first term is 10x raised to the power 4.
Yes, then?
Ma'am, next is 3x raised to the power 2.
Okay, then?
Ma'am, minus 7x raised to the power 3.
Very good. Now, what is the power of this term?
Ma'am, 4.
4. Now I'm going to write the powers, okay? 4. What is the power of the next term?
Ma'am, 2.
And then the next term?
Ma'am, 3.
Now, which is the highest of these powers?
Ma'am, 4.
4. So we say that the degree of this polynomial is 4. Okay? Is that clear?
Yes, ma'am.
Okay. Now we'll take a look at this again. So we talked about the power and degree. Oh yeah, so we were talking about that question, right? We got so carried away. We were taking a look at the question, and the question was root 2 is a polynomial of which degree? So Mridula, now would you like to change your answer?
Yes, ma'am.
Yeah, what would it be?
Ma'am, it's C.
Okay. So let's take a look at this. So root 2, this is the polynomial. Our polynomial is root 2. Can I write it as root 2 multiplied by x to the power 0? Can I write it like this?
Yes, ma'am.
Why? Because x to the power 0 is 1. So we're basically writing root 2 into 1, which is the same thing as root 2, right? So yeah, so we can write this. Now carefully look over here and tell me what is the power of this?
Ma'am, 0.
0. So what is the degree of this polynomial?
Ma'am, 0.
Right. So is it clear now, Mridula?
Yes, ma'am.
Okay. So once again, the degree of a constant polynomial. This is called a constant polynomial. Why? Any ideas? Yep. Anyone?
Ma'am, I guess it's, ma'am, it's it called the constant polynomial, ma'am, because it never changes.
Very good. That's one way to think about it. Also because this is a constant, right? When we talk about algebraic expressions, if you recall, we used to talk about, well, in any expression or in any term, as we looked at in our previous class, any term is made up of two things. You have a constant and you have a variable, right? You have a constant and you have a variable. So the constant over here in this polynomial, the variable is not visible because the variable is basically it's disappeared because it is converted into 1. The variable has a power of 0. So essentially there is no variable. There's only a constant in this. Only a constant over here. That's why it's called a constant polynomial. So now, can you tell me, either of you, degree of a constant polynomial is always
Whole number.
0. Okay, degree of a constant polynomial is always 0 because, well, this over here you have root 2. What if you had something like 1 by 4? 1 by 4 is a number. Yes, of course it is a number. But if we say this is a polynomial, then you can write it like this. And you can see that the power over here is 0. So the degree of this polynomial is 0. That's why we are saying that whenever you have a polynomial in which you can't see any variable, that means the degree of that polynomial is 0. All right. So I hope this is clear. Let's move to the next question. Yeah. So the third question, degree of the polynomial 4x to the power 4, 0x to the power 3, and so on is
B.
B5.
okay. Both of you are saying it's B5. So that is like that is a good guess. But how about just a second. So over here we had 4x 4x to the power 4 plus 0x to the power 3. So just a second. Yeah, 0x to the power 3 plus 0x to the power 5 plus, and then we have 5x plus 7. So both of you are saying that the degree of this polynomial is 5. How about if I add a few more terms? I mean, I can add 0 how many times I want, right? How many ever times I want. It's not going to change the value of it. So how about if I add 0, if I decide to add 0 again, because this is 0x cubed, this is 0x to the power 5, I can add 0x to the power, I don't know, let's say 8. Then does the degree of the polynomial change to 8? Does it sound right, or is there something wrong happening over here? How can we correct this? Something's not right somehow. Yes? Any ideas? I'll be waiting for a
ma'am.
response. Yes, Hamna? Okay. Mridula, what about you?
No, ma'am.
Okay. So, first of all, tell me that the question that I just stated in front of you, that I can add how many ever zeros I want, and then I can make this x to the power, let's say 17. Then the degree will keep on increasing. Should this happen, or is this should this happen, or should this not happen? Is this wrong? Does it seem right, or does it seem wrong to you somehow?
It's right, ma'am.
Okay. So Hamna, you're saying that there's no problem, the degree can change. So basically, if I write, okay, let's take another example. If I write a polynomial over here, 5x to the power 2 plus 3x to the power 4, okay, and I give it to, let's say, a class of 50 students, okay, and I ask each of the 50 students, tell me what is the degree of this polynomial. And if every student wants to add how many ever zeros, let's say Hamna adds to it 1 0, and she says, well, I can add 0x to the power 20, so the degree is 20. Okay, then I go to another student and she says, well, I can add 0x to the power 40. So the degree becomes 40. So what happens is I have just one polynomial over here. And if I am allowed to do this, okay, listen carefully. If I am allowed to do this, if everyone is allowed to just add a 0x to the power whatever they want, then we will have as many different answers to the degree of the polynomial as there are people. Everyone will say whatever they want. So does this sound fair, or should we have a proper definition that no, the degree of this polynomial is just one particular thing and it cannot change? What do you think?
Ma'am, degree cannot change.
Right. So degree is fixed. Okay, the degree of a polynomial is fixed. So in this question that we were talking about, in this polynomial that we were seeing, the degree of this will be 4. Why? Because when you see the degree of a polynomial, you don't just see, oh wait, let me just take a look at which is the highest power, and you say, oh, this is the highest power, so this must be it. That it looks like that at the first glance, but you should look at the non-zero terms. Okay, remember this, the non-zero terms. Because if you talk about the zero terms, then there can be any number of zero terms, and then we don't have a fixed standard. So we don't look at this, we don't look at this, we only look at the non-zero terms. So Mridula, what is the degree of this polynomial?
Ma'am, 4.
Very good. Hamna, is it clear?
Yes, ma'am.
Ma'am, can you
Okay.
explain it one more time?
Yeah, sure. So which part did you not understand exactly?
Ma'am, the powers.
Sorry. Yeah. So just a second. So Mridula, did you understand this part, that we said that if we allow people to just add any number of zero terms that they want, any number of zeros, then they can make it 0 to the power 0 into x to the power of anything. But it doesn't work like that, right? The degree has to be fixed. So if the degree is fixed, that means we don't consider the zero terms. We don't consider the terms that have zero in them. Why? Because
How we
if you,
differentiate, ma'am, how we differentiate between zero and non-zero terms?
you can just take a look at the coefficient. Over here it is 0. Over here also it is 0. So anything multiplied with 0 is what? 0. So basically this term doesn't count because this term is 0. This term also doesn't count because it is 0. So essentially we are left with only 3 terms, the terms which are colored in brown. We are left with only 3 terms. The other 2 terms are not counted because they equal to 0. Okay, for example, Mridula, when you, let's say when you were little, you were like second or third grades, and you were given a question, and we used to, if you have a question like 5 plus 0 plus 2 plus 0 plus 7, okay, do you sit and count the zeros every single time you make an addition? Or do you just say, well, I'm not going to take a look at the zeros at all because they don't matter, they don't count, because 0 means nothing. So I'm not going to consider them at all. So my problem is just reduced to 5 plus 2 plus 7. This is what we do, right? So it's a very similar situation. It's the exact same thing. You just don't consider the zero terms at all because they are 0. Is it clear now? How do you differentiate? You just take a
Yes,
look at the
ma'am.
coefficient. The coefficient is 0, so the whole term becomes 0. Okay. So let's take a look at the next question. Degree of the zero polynomial. Okay. What is the zero polynomial? Let's just take a look at that. So we have taken a look at different types of polynomials, right? we talked about the constant polynomial. What is the constant polynomial? Or how about we do this? Let's take a polynomial which is 7x to the power 4 plus 2x square plus 3. Okay, this is one polynomial. Another is, let's say, 3x cube minus 4. Or yeah, another one is, yes, Hamna, you'd like to say something?
Ma'am, you said that the degree of a constant polynomial is always 0. So if the constant is 0, its degree will also be 0.
Yeah, so let's take a look at that. Okay, and let's just take a look at that. So we have these polynomials, and then let's say we have 2x, okay, and I have another polynomial which is 2, and then I have another polynomial which is 0. Now, you at first glance, you might say, well, these two are almost the same thing. But the thing is, the degree of a 0 polynomial, okay, if we take a look at this, if we take a look at the fourth polynomial, 2, right? 2 is what? 2 is x to the power 0. Why? Because, okay, let me just explain it over here. So this is 2. This can be written as 2 into 1, and this can be written as 2 into x to the power 0, right? So you understand where the x to the power 0 is coming from. But when we talk about 0, we can write this as 0 into anything. We can write this as 0 into x to the power 20 also. Because if we do that, then it is again equal to 0 itself. So you could write it as x to the power 20. You could write it as x to the power 50. You could also write it as 0 into x to the power 0. You could also write it as 0 into x to the power 1. So why are we able to have so many different powers of 0? I'm sorry, so many different powers of x over here, so many different powers of x, because we are free to do that since the coefficient is 0. So anything multiplied by 0 is 0 itself. So it doesn't matter what power we put, we are going to get 0, right? The point I'm trying to make here is, with 2, with a constant polynomial, you could not do that. You can't say, well, we can also write this as 2 into x to the power 1. You cannot write it as that. Why? Because the moment it becomes x to the power 1, this thing becomes 2x. And 2x is definitely not the same as 2. They're entirely different things. But over here, with 0, it is a special case. Why? Because with 0, you can just multiply it with x to the power anything and you will still get 0. So in this case, we say this is the 0 polynomial, okay? 0 is known as a 0 polynomial as well. So in this case, we say that the degree of this polynomial is not defined, right? Because we can't define the degree. You can't define it. In this case, you could define it. It was one definite degree. You could point it out and say, well, this is the degree, and everyone had the same answer, the same definite answer, right? Which is, well, the degree is 0. But in this case, you can't do that because you're free to multiply it with whatever you want. So is it clear now, Hamna?
Yes, ma'am.
Mridula, is it clear to you as well?
Yes, ma'am.
Okay, cool. Good. So degree of the 0 polynomial is not defined. Okay. All right. Now let's take a look at evaluating polynomials. Okay. Let's take a look at evaluating polynomials. So if I have something which is just a sec. Okay. So if I have something which is 5, just yeah, 5 x to the power, I don't know, 2. Okay. Minus 2x cube. Yeah, minus 2x cube. And then plus, let's say 3. And if I say evaluate this polynomial for x is equal to, let's say 1. Okay, so what do you have to do? This basically means that wherever you have x, just replace that with 1. Wherever you have x, just replace that with 1. And I think you've done this in your previous classes as well. So can you tell me the answer for this?
I'm 6.
Very good. The answer is 6. Hamna, are you getting the same answer? Hamna, am I audible?
Yes, ma'am.
Yeah. What answer are you getting, Hamna?
6.
Okay. So let's do another one. Let's do another one. Let's do the sixth one first. And then we'll go to the fifth one after this. So can you solve the sixth one?
Ma'am, it's A.
Okay, Mridula says it's minus 6. Hamna? Hamna, you trying to solve it? Yes? I'm not able to hear you. Okay. Hamna, what's your answer? It's okay, even if your answer isn't right, it's totally fine. We'll see where there's a mistake, right? So
Negative 6, ma'am.
yeah, okay. So that's the right answer. Let's move on. Okay, so now let's move on to the fifth question. So the thing is, what happens with polynomials is that we give them a name. Okay, we say, well, okay, I'm going to call this P of X. P means polynomial, or it could be anything else. It could be Q, it could be S, it could be G, anything. Okay, but we're naming this P of X. That means it is a polynomial in variable X. Just a minute. It is a polynomial in variable X. Okay. I could have something which is like Q of Y. It is Q of Y. And I could have, let's say, minus 7y square plus 2 y cube. Okay, so this is a polynomial in the variable y. So therefore we have written it as, we have named it as Q of y. So this is called P of X, Q of y, and so on. So let's take a look at that question of ours. Yeah, fifth question. Can you solve it?
Ma'am, which question?
Question 5. Yes, were you guys able to solve it? Okay, how about we do it together? Okay, so just a second. We have our P of X, or let me just, yeah. So P of X is equal to X square minus, minus 2 root 2 X plus 1. So they're asking what is the value of P of 2 root 2. So what that means is that wherever you have X, you have to just replace it with 2 root 2. Is it clear now?
Yes, ma'am.
Yeah, so what you need to do, just replace X with 2 root 2. So this becomes 2 root 2 whole square, and then minus 2 root 2, and then replace that X with 2 root 2. So this is 2 root 2, and then plus 1. What's the answer? Come on, it's really easy. You don't have to sit and solve the whole thing. Okay. So look here.
Yeah, ma'am, it's 1.
Yeah, it's 1. Why is it 1? It's just you can just look at the equation and say that it's 1. Why? Because, well, this is 2 root 2 whole square. This is also 2 root 2 whole square. This is 2 root 2 whole square, and then we have minus, and then again 2 root 2 whole square. So you can just cancel it out. So the answer is 1. Hamna, is it clear?
Yes, ma'am.
Okay. So let's go to the next question. Yeah, let's go to the 7th one. Okay, this is an interesting one. Let's see if you guys can do this. If P of X is equal to X plus 3, so our polynomial X plus 3, its name is P of X. We are calling it P of X. They're saying if P of X plus, I'm sorry, if P of X is this, then what is P of X plus P of minus X? So what does P of minus X mean? Hamna, what do you think that P of minus X means? Any idea? Okay. Hamna, um if you're having any thoughts in your mind, you can just say it out. If not, you can just say no, it's not clear, so that we can move forward. But like, please respond. Vidula, Hamna, any of you?
Ma'am, it means that polynomial or polynomial is the degree of polynomial is X.
Okay.
Ma'am, X, ma'am, we put the value of in the equation. Ma'am, we put X plus 3 in the equation. Ma'am, is X.
Okay. Okay. All right. So we said over here, if you look over here, we said P of X means this. So P of 2 root 2 means this. Now, if I take another polynomial, let's say if I take P of Y, okay, this is equal to y square plus 2y minus 1. Okay. Now, if I replace over here in the input, if I replace y with anything at all, absolutely anything at all, then this change will be reflected in all the y's across our equation, across our polynomials. So if I say p of, let's say, 2, so you will immediately, what you'll do is you will just replace every single y over here with 2. So this will become 2 square plus 2y minus 1. Okay. Now if I say p of minus 3, Hamna, what should I write?
Negative 3 square plus
Yes.
2
Yes.
minus 3
Mm-hmm.
minus 1.
Very good. So this is basically 2 multiplied by negative 3, not 2 minus 3, right? So I hope you guys will make a mistake there. Now, Mridula, how about if I write p of x over here? What will this become?
Ma'am, x square plus 2x minus 1.
Very good. Excellent. Now, if I say I'm going to change this with p of minus y, what does this become?
Ma'am, minus y square plus 2.
Just a sec. Mridula, just a sec. Should I write it as this or should I write it as this? Which one? First or second?
Ma'am, first.
Very good. Because a lot of students make this mistake and the results turn out to be disastrous. Anyway, next, yes, Mridula?
Ma'am plus 2.
Hmm?
Ma'am, bracket opens. Ma'am, x, ma'am, no, minus y, ma'am, minus y, bracket 2, minus 1.
Yes, minus 1. Very good. Excellent. So I hope it is clear what we're supposed to do when we have such a change in the variable, right? So now if you take a look at it again, the question, p of x is x plus 3, then p of x plus p of minus x is equal to what? So what you're going to do first is you're going to say, okay, they said that p of x, or just a sec, p of x, p of x is equal to x plus 3. So now what should, if this is p of x, then what is p of minus x? Hamna, quickly. Yes, Hamna?
Negative x plus 3.
Very good. So we just replaced that x with whatever was in this bracket. Okay, so this is p of x and this is p of minus x. And the question, if you recall, it asks us what is p of x plus p of minus x equal to. So what do we have to do here? Sorry. Yes? What do we have to do now?
And we have to put the value of x. Given in the is given in the question.
The value of x is not given in the question. The question just says, the question is just giving you this much information. They are saying p of x is equal to, basically they're giving you a polynomial, p of x, and the value of that is x plus 3. And they're saying, well, what should be the value of this? So you have found out what is p of minus x. You needed this, p of minus x, and you have found what that is going to be. So all that you need to do right now is just add these two, right? You add these two. So now tell me, what is the LHS going to be? P of x plus p of minus x? Yes or no?
Yes, ma'am.
Okay, Hamna, is it clear?
Yes, ma'am.
Okay. And then Hamna, what is the RHS going to be?
x plus 3 plus negative x plus 3.
Very good. So it's going to be sorry, x plus 3 plus, and then we can put like a bracket over here, negative x plus 3. Okay. So, Hamna, what should be the final answer? Okay. Hamna, what can I do with this x and this x? Yes, Hamna? Hamna, are you there? Okay, Mridula, what can I do with this x and this x?
Ma'am, first we open the bracket. So
Yes.
the equation will be x plus 3, x plus 3 minus x plus 3.
Very good. So, what do we have then?
Ma'am, positive x and negative x get cancelled out, and
Exactly.
ma'am, the answer is 6.
The answer is 6. Okay, so let's take a look at what the options were. The options were, okay, so we have p of x plus p of minus x. So what is the correct answer now? Option D. Okay. Hamna, was
Yes,
this
ma'am.
clear? Any doubts? Hamna? Okay.
Yes, ma'am.
Right. So, yeah. So was this question clear, the seventh one?
Yes, ma'am.
Okay. So zero of a polynomial is a concept that we will talk about in the next class. Right now, I just want to introduce you to it's a very small concept which is called leading term and leading coefficient. So till now, you've seen that we've just been writing um, our polynomials very randomly. Like we had, we have this over here and then we have this over here. But the standard form of a polynomial is you have whatever the terms are, you arrange them in descending order of their power. Okay, descending order of power. Okay, that's what you do. So can you, Mridula, can you tell us what the standard form of p of x in this case would be? Remember what I said, descending order of power. Yes, Mridula?
Ma'am, minus 2x is to the power 3.
Yes, minus 2x to the power 3. Then?
Ma'am, plus 5x raised to the power 2.
Yes.
Ma'am, plus 3.
Very good. Hamna, what about the second one, q of y? Yes, Hamna?
2y raised to the power 3
Yeah. Minus 7y square, right? Okay. Now, another concept that we have is called, there's a term called leading coefficient. Leading coefficient means leading coefficient. Okay? Leading. Leading coefficient. And before that, we have something called the leading term. So what do you think leading term means? Any ideas? I think it's pretty obvious from the name itself. What does leading term mean? Yes? Leading. It's okay, even if you give a wrong answer, it's totally fine. Yeah.
Ma'am, which has the ma'am, which is a greatest in the equation.
Yeah, that makes sense. Greatest in what sense?
Ma'am, term.
Coefficient or greatest in terms of the power? Greatest in what?
Power.
Yes, right? So basically what that means is, now since we have uh, arranged this in our standard form, that means the term which is the greatest in power, or you can say the highest degree term is always going to be the first term. So this is known as the leading term. Okay, very simple, nothing complicated. This is the leading term. The leading coefficient is basically the coefficient of this term. So in the first case, what is the coefficient, Hamna? What is the leading coefficient of P of X? Hamna? Mridula, what is the leading? Yes, Hamna?
Ma'am, I did not understand it.
Okay. So I'll just repeat it, just a sec. So leading coefficient, did you understand the concept of a leading term, Hamna? Um, Hamna, did you understand what a leading term means?
Yes, ma'am.
Okay, so can you tell me which is the leading term in the first polynomial in P of X? Hamna? Which is the leading term?
Negative 2x cube.
Very good. So the leading term over here is this. Leading coefficient is nothing but the coefficient of this term. The coefficient of the leading term. Okay. So now can you tell me, Hamna, what is the coefficient of the leading term, or I can say what is the leading coefficient in P of X?
Negative 2.
Very good. Okay, so it is negative 2. And Mridula, what is the leading coefficient in P of Y? Sorry, Q of Y?
Ma'am, it's 2.
Yes, over here it's 2. Okay, so let's keep it till here, because in the next class we'll talk about zeros of a polynomial. And the thing is, zeros of a polynomial is a very interesting concept because it has many applications in our real life as well. So we'll talk about it in the next class. Any doubts?
No, ma'am.
Okay, then I guess that's it for today. Thank you, class.
Good night, ma'am. Thank you.
Good night. Bye.
Good night, ma'am.